Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x squared minus 6 squared minus 6 is equal to x. And what I'm first going to do is I'm actually going to set a equal to x squared minus 6. So I'm going to set the variable a equal to x squared minus 6. And if this is true, and if we substitute in a for x squared minus 6, our equation would be a squared minus 6 is equal to x. So now if this is true, and let's say this is equation 1 and this is equation 2. Now, I'm actually going to subtract both of these. I'm going to subtract x squared minus a squared. So x squared minus a squared. And what ends up happening is we get the result as a minus x. X squared minus a squared is equal to a minus x. So if we have something in the form m squared minus n squared, this can also be written as m plus n times m minus n. Meaning x squared minus a squared is equal to x plus a times x minus a. And now if I add x on both sides, we would get plus x, and then if I subtract a on both sides, we would get minus a, and now because there's nothing left on our right hand side, we would simply have 0. So now I'm going to factor out x minus a from this. So x minus a times x minus a, x plus a times x minus a divided by x minus a is simply just x plus a. And x minus a divided by x minus a is 1. So we have x plus a plus 1. And this is equal to 0. So now this would actually give us two equations. We would have x minus a is equal to 0. And for this, if we add a on both sides, we simply get x is equal to a. And if x is equal to x squared minus 6, because remember, a is equal to x squared minus 6 and x equals a. That means x equals x squared minus 6. And if we subtract by x on both sides, so we get 0 is equal to x squared minus x minus 6. Now we have a quadratic equation, and this would actually be simplified to 0 is equal to x minus 3 times x plus 2, meaning our two solutions for x would be x is equal to 3 and x is equal to -2. However, there is still another equation. We still have x plus a plus 1 equals 0. So if x plus a plus 1 is equal to 0, that means that x is equal to, I'm going to subtract everything and move it to the right-hand side, negative a minus 1. And I'm actually going to plug in a. A is x squared minus 6, so this means x is equal to negative 1 times x squared minus 6 is negative x squared plus 6 minus 1, and 6 minus 1 is 5. So we have negative x squared plus 5. So now if we subtract x on both sides, we get 0 is equal to x squared plus x minus 5. And if we plug this into our quadratic formula, we get negative 1 plus or minus the square root of 21 over 2. So these are our two other equations. We have negative 1 plus the square root of 21 over 2 and negative 1 minus the square root of 21 over 2. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n is equal to 2016. Now, by knowing this, we could actually decipher a couple things. Because this is positive, 2016 is positive, we know that m has to be greater than n. Because if m was negative, then this would actually be negative. And if n was greater than m, this would actually be negative 2016. So by knowing this, we could just say that m is equal to n plus k. K being a constant. So now if I subtract k on both sides, I get m minus k is equal to n. So now I'm actually going to replace m with, I'm going to replace m with n plus k. So now we have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now this can also be written as 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 2016. And now if I factored out 2 to the power of n from this, I would get 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So now 2016, well, this is actually equal to 32 times 63. So now we have 2 to the power of n times 2 to the power of k minus 1 is equal to 32 times 63. And now 2 to the power of n, this is actually going to be an even number because 2 to the power of anything is going to be even. And 2 to the power of n minus 2 to the power of k minus 1, well, that's going to be odd. Now 32, well, that's an even number, so I'm going to write e for even, and 63 is odd. So meaning we could just say that 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So if 2 to the power of n is equal to 32, then n is equal to 5, because 2 to the power of 5 is equal to 32. And we have 2 to the power of k minus 1 equals 63. If we add 1 on both sides, we get 2 to the power of k is equal to 64. Meaning k is equal to 6. So now if n is 5 and k is 6, well, we could simply plug these into this. M is equal to n plus k, and n plus k is 5 plus 6, which is 11. So m equal to 11. So now these three are our values.